Root mean square value.
Okay, so welcome back to today's lessons by Solomon and David Peterson. And today we'll be dealing with root mean square value. Root mean square value. But mind you that we are still talking about alternating current circuit. Alternating current circuit. Okay, so what is a root mean square value, and how do we even find a root mean square value?
The root mean square, or the effective value of an alternating quantity, is the value of a direct current which, when flowing through a given resistance for a given time, produces the same heat as produced by the alternating current when flowing through the same resistance. So the RMS value of the alternating current is, when we have I, may be equal to Ft. Now, how do we find the root mean square value? First of all, you identify the cycle of the waveform. Secondly, you note the period. Thirdly, you square the cycle. You find the area under the square cycle. You divide the area by the period. And lastly, you take the square root of the result in step 5.
Okay, so now realize that we can derive the root mean square equation, or the formula for us to find the root mean square value, from the average value. So now, from previous videos, we realize that the average value is 1 over t integral of 0 to t times the function dt. Okay, so now, if you want to find the root mean square value, which is I RMS, then a simple root. So we know the square root. So root and the mean, which is the average value, and this is the mean. So the average value is 1 over t to t, the function f of t dt, and square. So the mean value, or the function of the mean value, should be squared. So that means the function of the mean value should then be squared. Okay. So if this is this, sorry, should be squared. Okay. And this same value, as we said, the average value is the same as the area under the function divided by the period. This can also be equal to the area under the square function divided by the period. And that is the root mean square value. The root mean square value. Okay. Now let's take a typical example, like we did for the average, and let's look at how we will go about it. So, taking the example we solved under the average, so the p value, so it's I of t, and it's t. It's 10, 0, 1, 2. Okay, so let's solve this example where we'll find the RMS. So the root mean square value is simple as what? The RMS. Okay, how do you go about this? First of all, the IRMS is simple. The square root of 1 over t integral of 0 to the period. That looks at the limit, the function f of t squared. Okay, so now what we need is one, we need the period t, and we need the function. So now we need the period and we need the function f of t. Okay, so now it's very simple here. How do we get the period? So from the previous videos, the period is the cycle. So if I number here A, B, C, then the same thing is repeating itself here. So the period becomes from 0 to 1, 1 to 2. So the period here is what? It's 1. That is the duration under a cycle. So this is a complete cycle. This is another repeating cycle. So the duration under a complete cycle here is 1. So the period is 1. But how do you get the function? The function here is what? I of t. I of t here is the function. So that means the function for here is I of t. But how do you find the I of t here? Because it was not given to us. But there is a way we can find it. You can consider AB, line AB within here as the focus, because that is what is giving the peak. You can also consider it easy to find there. So now what do? We can use equation of a straight line to find the I of t. So upon using the equation of a straight line, the equation of a straight line states that y minus y1 will equal to the gradient times x minus x1. Okay. Now you realize that point A here is 0, 0, and the point B here is 1, the x value is 1, and the y value is 10. Okay. Now y here is the value of the x-axis, and that is the function I of t. And the x is the function that is time, is t. Okay, so now you can have I of t minus y1, which will give the gradient t minus x1. So now from here, if you want to find the gradient from here, the gradient is simple y2 minus y1 by x2 minus x1. And that will give you 10 minus, when you come here, 0 divided by 1 minus 0. So the gradient is 10. So upon having the gradient to be 10, then we can put it back into the equation. So the I of the function t minus y1, which is 0, is equal to 10 into bracket t minus y x1, which is also 0. So from here, you get the function I of t to equal to what? 10t. So the function here for this particular waveform is 10t. So therefore, the function we're using is 10t. But take note that in the RMS, or the root mean square value, it says you should square the function. So now, if the function is this way, the f of t all squared, which is the function I of t all squared, will then become 10t all squared, which is 100t. So if it is 10t all squared and it's 100t, then RMS is simply equal to the square root of 1 on t, which is 1. Integral of 0 to 1. The function f of t squared, which is 100t, which is 100, just 100t squared, so which is 100t squared dt. Okay, so our focus here is what? To find the integral within this particular function. Okay, so upon solving or finding the particular within this particular function, okay, you can continue from here. So the IRMS will now be equal to the root of 1 on 1 is the same as 1, or we can either decide not to bring it. So the integral of, now we have to solve, we have to integrate this function. So from integrating this function, we take the integral value out. Okay, so when you integrate this function, we have 100t keep on 3, and we put our 0 to 1 here. So now we put our 0 to 1 over there. Then the RMS, those are our limits. 0 to 1 are our element. Is equal to the square root of 101 keep on 3 and minus 100 0 cube on 3. So therefore the IRMS will simply be equal to the square root of 100 on 3, which is equal to 5.7733 ampere. So this is the value of the RMS. But aside this two, there is an alternative way to simplify it, and the alternative way is that we said the IRMS is also equal to the area under the function squared divided by the period. Okay, so if you are dealing with that, the alternative way, you can decide to find that area and we divide by the period. So now, this is the function f of t. We squared that particular function. So now, if you take the cycle and we square the cycle, so now the cycle here has a peak value. So the peak value for the cycle here is 10. So now we square that peak value, which is equal to 10 squared. And it's equal to what? 100. So now if you square that peak value as 100, now to find the area, you have to note this. The area under a right angle triangle. Right angle triangle is always b a square. Sorry, under a squared right angle. You have to take note. The area under a squared right angle triangle is always bh squared divided by 3. So now this is a squared right angle triangle. If you want to find, so you have to square here. When you square here, it's more or less like the function is squared. So if you're using the other alternative, that's what you go by. You square the peak value. So this one is a right angle triangle. So how do you find the area? So the area is the base, which is the 1, times the height, which is the 100 squared, and it's the same as 100. The 10 squared, which is the same as 100, divided by 3. So you get it as 100 on 3. So if you get that area, then the IRMS is simple, equal to that area under the ft squared divided by t. So therefore, 100 on 3, sorry, divided by t, 100 on 3 divided by t. And take note, the RMS is always what? Square root. So you have to square this one. It has to be in the square root. So this one still gives the same as what? 100 on 3. But when you square this, then we are getting 5.7733 ampere. So this is an alternative way to go about finding the root mean square value. Thank you guys very much for this time.